Alright, so let's learn about polynomial functions. Last time we learned about power functions. So a polynomial function is basically a sum of power functions whose exponents are positive integers. So if we look at the power functions 4x to the 7, 5x cubed, minus 2x squared, and 10, if you add them all together, the result is a polynomial function. F of x equals 4x to the 7 plus 5x cubed minus 2x squared plus 10. So that is a polynomial function. It's written in standard form because the exponents, the positive integer exponents, are in descending order. So 7, 3, 2, and then 0 for 10. The degree is basically the highest exponent. So the degree is 7 for this one because the highest exponent is 7. The terms are each individual power function that is added to get the polynomial function. So the terms will be 4x to the 7th, 5x cubed, minus 2x squared, and then 10. This last one is called a constant term. And then the first one, 4x to the 7th, is called the leading term. The coefficients are basically the numbers that are coming from the variable. So the coefficients of this polynomial are going to be 4, 5, and negative 2, and then 10. The leading coefficient is basically the coefficient of the x with the highest power. And then, as we said, the standard form is basically in descending order of exponents. All right, let's see some examples of polynomial functions. So notice that the exponent is 3 in this case, and for this one is 1, and then for this is like x to the 0. So these are all positive integers. So yes, this is a polynomial, and the degree is 3 because that's the highest exponent. Notice that the exponent for this x is negative 3. Negative 3 is not positive integer. So no, the second one is not. And then the third one, notice that 1/3 is not an integer. Not a positive integer. I mean, it's a positive number, but it's not an integer. So this one is not a polynomial as well. So no, no, yes. Alright, so now that we know how the polynomial function looks like, our next goal is to see how the graphs look like, and then we use them to solve problems. I just wanted to mention that in general, a polynomial function is written like this: an, which is the leading coefficient, times x to the n, plus an minus 1 times x to the n minus 1, plus all the way to a2 x squared, a1x, plus a0. So this is just like a general form of it. So this means that n will be the degree, an is the leading coefficient, and then a0 is the constant term. Alright, so let's look at some examples. So let's graph the polynomial function f of x equals x to the 4th minus 10x squared plus 9. First using a small window and then zoom out on a bigger window. So if you go y equals, turn your calculator on, quit. If you go to y equals and plug in the polynomial function, and then to the window, let's put negative 4, 4, and then 1, and then negative 20, 50, and then 10. And let's see how the graph looks like. And so this is how the function looks like. So let's graph it in here. We see that the x-intercepts happen at negative 1, negative 3, and then 1 and 3. So let's graph this quick. Okay, so I just did the graph. So what is the domain of this polynomial function? We see that x can be anything. I can plug in x as 1,000,000 or x is negative 1,000. So the domain is all real numbers, and we write that by negative infinity to infinity. What is the end behavior of this polynomial function? So basically, the end behavior, we're interested to see how the function behaves. Where does it go as x grows really large, as x goes to infinity, or on the right, right? So if you see, if x is 4, the function goes up. If x is 5, the function goes up. If x is 1,000, the function will go up. So y goes to infinity. On the right, the function rises. On the left, as x goes to negative infinity, also the function goes up to infinity. So on the left, the function also rises. So look at the graph A, so this A, and locate the x-intercepts. The x-intercepts happen at -3, at -1, at 1, and 3. So to list the x-intercepts, basically it's -3, 0, -1, 0, and then 1, 0, and 3 zeros. That's why the intercepts are also called zeros or roots of the polynomial. They basically make the y 0. When x is 1, the y is 0. When x is 3, the y is 0. So if 1 is a 0 or an intercept, we say that x minus 1 is a factor. If 3 is a 0 or a intercept, we say that x minus 3 is a factor. If -3 is a 0, we say that x minus -3 is a factor, which this is the same as x minus -3, which is +3. And then if -1 is a factor of a 0, x minus -1 is going to be a factor. So that turns into x plus 1. So the factors are x minus 1, x minus 3, x plus 3, x plus 1. To write f in factored form, so basically f given here is written in standard form, but if we wanted to write it in factor form, basically we're going to take all the factors and multiply them together. So this is going to be f of x equals x minus 1 times x minus 3 times x plus 1 times x plus 3. And we can verify that I don't have a coefficient in here, hence that it's 1, by verifying that when f of 0 is equal to, what does it have to be equal to? F of 0 will have to be equal, I plug in 0 for x, so I must get 9 out. So let's see from this what would be f of 0 be. It will be -1, because it's 0 minus 1, times 0 minus 3, times 1, times 3, which is equal to 9. So this is the correct factored form. If we look at the graph now, what can we say about it with respect to the y-axis? You notice how the graph is a mirror image of itself by the y-axis. So this is the y-axis. So this point right here is mirrored in this point. This point right here is mirrored in this point. So when that happens, we say that the function is actually an even function. So it's the graph f is symmetric by the y-axis. It means f is even. So just like numbers, functions can be even or odd. Actually, they also can be neither. We'll see in a second. Now look at graph B and describe the function f. So now if we zoom out basically and we change our window, for x we leave it the same, but basically we zoom out for y. So I'm going to go back and I'm going to change my window. I'm going to change my window for the y. So it's going to be -20 to 3000. So basically I'm looking more up. And then 100. No, I should change my x as well. -20 to 20, let's see. So see how the graph looks basically just like a parabola, or like the power function x to the fourth. So in the long run, this polynomial function, which is x to the fourth minus 10x squared plus 9, behaves just like the power function x to the fourth. Okay? So this is what we're going to say here, if I'm going to be able to scroll. Okay. Come on, dude. Okay, so let's get back to where we were. So f behaves like the power function x to the fourth. Now, where is the function increasing? We see that the function is increasing from here to here, and then from here to here. So this function is increasing from x is -2 to 0, and then from x is 2 and infinity. So the function is increasing from -2 to 0, union to, said 0 and put infinity, from 2 to infinity. So on this interval for x, the function is increasing, right? See how it's increasing? And it's increasing, and it's decreasing for -infinity to -2, union 0 to 2. Okay, another new vocabulary, another thing that we're looking at is a turning point. A turning point for a polynomial function is basically the point where the function changes from increasing to decreasing, or from decreasing to increasing. So it's basically these points right here. So the function changes from decreasing to increasing. So I have one turning point here, and then I have a turning point here, and then another turning point there. So this function has 3 turning points, or you could call them bumps, 3 bumps. How many turning points does it have? 3. So it has 3 turning points, and its degree 4. And its degree is 4. We'll see if there's a connection between the number of turning points and the degree. Okay, so next you can solve this one by yourself. So follow exactly the steps that we followed for the previous example. So the only difference is going to be, what can you say about its graph with respect to the origin? So we'll do that one together. So you can pause and do this by yourself, and then check your answers.